All right, so what we're going to talk about next is operations with radical expressions. So we know how to simplify them. Do we know how to do things like add, subtract, and multiply with them? So first thing we need to talk about is what are like radicals. Just like variables or like terms have the exact same variable part, like radicals will have the exact same radical part. For example, we might have something like the square root of 3 and the square root of 3. Those would be the exact same radical part. They both have a square root. They both have a 3 underneath. Looking at some more examples here real quick, if I had the cube root of 3 and the square root of 3, those are not like radicals, because this one has a cube root and this one has a square root. So they have to have the same value underneath and the same radical. If, for example, I have the square root of 5 and the square root of 7, because the value underneath, even though they are both square roots, since the value underneath is not the same, those would not be like radicals. I could do like the square root of x and the square root of x, cube root of x and cube root of x. Those would all be like radicals. So now that we know what they are, if at any time we want to add and subtract like radicals, what we need to do is simplify first. So in other words, if you're given, say, like the square root of 16, that breaks down to 4, or the square root of 20, that has a perfect square in it. So looking at these three examples between adding and subtracting, I noticed that the first one is an addition problem because there is an add sign in between. What I noticed before when we were doing operations with imaginary numbers is that when people saw parentheses, they automatically assumed they were supposed to distribute and do some kind of a multiplication problem. This is an addition problem. So I look at my first set of parentheses and I ask myself, is there anything to distribute? I realize there's not, so I'm just going to drop my parentheses, giving me 2 square root of 5 minus 4 cube root of 5. I also know that if I were to distribute a plus, a positive times a positive stays positive, a positive times a negative stays negative, so I really can just drop those parentheses also. And now from here, just like I say 2x plus 3x is 5x, and I don't change my variable part, I'm going to say 2 times the square root of 5 and negative 8 times the square root of 5, which are like terms because they have the exact same variable part, is negative 6 square root of 5. And negative 4 times the cube root of 5 and positive 6 times the cube root of 5 is going to be positive 2 times the cube root of 5. Even though these are both 5, since they have different indexes on the radicands, I'm not going to be able to combine them in any way, giving me this for my final answer. If I look at my second example, I right away notice that this is a subtraction problem. Very, very similar to my addition problem in the aspect that my first set of parentheses have nothing to distribute, so I'm just going to drop them. And as I'm dropping my first set of parentheses, I realize that the square root of 75 has not been simplified. So at the same time, I'm going to rewrite that as the square root of 25 times the square root of 3. And same thing with my 30. The 30 has a perfect square in it too, I believe. Perhaps not. Square root of 30 cannot be simplified on second thought, so I will leave it as the square root of 30. And looking at my second set of parentheses, now with a plus, I realize that when I distribute a plus, positive times positive remains positive, positive times negative remains negative, so nothing changes. However, a negative times a positive will become negative, and a negative times a negative will become positive, so I'm going to have to change this to be minus. I realize 27 is the same thing as the square root of 9 times the square root of 3. Negative times a negative here is going to become a positive. Square root of 20 I know is the square root of 4 times the square root of 5. Giving me 2 times square root of 25 will become 5, so 2 times 5 will be 10 square root of 3, minus square root of 30, minus square root of 9, which becomes 3 square root of 3, plus square root of 4, which becomes 2 square root of 5. Now from here I check for like terms. I see I have one pair of like terms, or like radical parts, that I can put together. 10 square root of 3 and minus 3 square root of 3 becomes 7 square root of 3. I have to leave the minus square root of 30 since there are no other radical 30s. I also have to leave the 2 square root of 5 since there are no other radical 5s. Looking at my third and final example here, I notice that this time I don't have any parentheses, so right away I can just go ahead and simplify my radicals and then combine like terms. I don't have to worry about parentheses. 20, just like up above, I realize has a perfect square of 4 in it, so I will rewrite it as 3 square root of 4 square root of 5 minus, I know 45 has a perfect square of 9 in it, so I will rewrite it as 9 square root of 5. And I know that 5 times 16 is 80, so I will write that as 4 square root of 16 square root of 5, giving me 3 times the square root of 4, which is 3 times 2 square root of 5, minus 3 square root of 5 plus 4 square root of 5. So from here I notice that all my terms are like terms. So 6 minus 3 is 3, plus 4 is 7 square root of 5. Again, not changing my radical part. That is adding or subtracting. Another thing I noticed the last time we did operations was with imaginary numbers, and there was confusion about when do I add and subtract, when do I multiply. So notice with all of these adding and subtracting problems, nothing was written right next to each other. I have the plus sign separating my two pieces, the minus sign separating my two pieces, pluses and minuses spread throughout. Whereas here on my first example here, they're written right next to each other. Writing right next to each other means multiply. When I multiply, I can think of it as distributing, or I can think of it as foiling, whatever I'm more comfortable with. So looking at the first one, I will do 3 times 5 and 3 times positive 2. My first times my first and my outside times my outside, however you want to think of it. And 3 times 5 is 15. 3 times the square root of the positive square root of 2 is positive 3 square root of 2. Multiplying my minus square root of 2 times 5, I get minus 5 square root of 2. Minus square root of 2 times a positive square root of 2 gives me a minus square root of 4. Because again, remember when we have radicals, we can multiply them and put them under the same radical. This then gives me 15. I see that these are like terms, so minus 2 square root of 2. I know that the square root of 4 simplifies to be 2. After doing that, I see the 15 and the 2 can be put together, giving me a final answer of 17 minus 2 square root of 2 after multiplying. Looking at another multiplication example here. I now have 4 minus the square root of 3 times 8 minus the square root of 6. Going through the same process, I'm going to multiply 4 by 8 and 4 by minus square root of 6, giving me 32 minus 4 square root of 6. Multiplying the minus 3 by the 8 and the minus square root of 3 by minus square root of 6. Minus square root of 3 times 8 is minus 8 square root of 3. Minus square root of 3 times minus square root of 6 is a positive square root. 3 times 6 is 18. And well, I see that I have, these are not like terms. So while over here I had like terms in the middle, here I do not. So at first I might think, well, then I'm done. I don't have many like terms. But I know that the square root of 18 can be simplified. It has a perfect square in it, giving me 32 minus 4 square root of 6 minus 8 square root of 3 plus square root of 9 square root of 2, which gives me 32 minus 4 square root of 6 minus 8 square root of 3 plus square root of 9 becomes 3 square root of 2, and while this doesn't look very nice in the aspect that there's multiple terms with multiple radicals, this is the best I can do because none of these are like radicals. Looking at a final example with multiplication here, I need to recognize that when I am squaring and there's adding or subtracting involved, I cannot distribute the square in. I can only distribute exponents if it's multiplication or division. So instead I need to take the definition of squaring, which tells me multiply it by itself. Doing that and distributing my 4 gives me 4 times 4, which is 16. 4 times a minus square root of 5. Distributing the inside minus 5 to both terms. Minus square root of 5 times 4 is minus 4 square root of 5. Minus square root of 5 times minus square root of 5 is a plus square root of 25. I have like terms and I can simplify this, giving me 16 minus 8 square root of 5 plus 5, which for my final answer gives me 21 minus 8 times the square root of 5. And there is one last thing I would like to talk about before finishing this video. Conjugates are two binomials that differ only by sign in between. So do you remember this formula we looked at before, a plus b times a minus b? These would be considered conjugates because this one's plus and this one's minus. Everything else is the same. Just the sign in between is different. Do you remember, the next question is, do you remember what happens when you multiply a plus b times a minus b? A squared minus b squared. Remember that special formula we had? So it works the same way with radicals. Notice if I have square root of a plus square root of b times square root of a minus square root of b, exact same except for the sign in the middle, so they're conjugates. I can follow this formula. I get square root of a squared minus square root of b squared, which gives me a minus b because my radical, or my square root and my square cancel. So looking at an example with this where we have numbers filled in for our letters, if I have 3 plus the square root of 7 times 3 minus the square root of 7, so I have it written here and I have it typed, either one you want to look at. Following my formula, this is just going to give me a squared minus b squared, which gives me 9 minus 7, which in this case simplifies to be just 2. So where might this be helpful? Well, that's what we're going to look at next. For now, we just need to know we can do the adding, the subtracting, and the multiplying. So as long as you've got this down, then you're good to go.